Hi, this is a video on converting from binary to decimal. So we use the binary numbers in computer science, and as we covered in class, binary numbers are zeros and ones. Okay, and whereas decimal numbers, we use the base 10, so decimal means base 10, and the digits that we use in a number would be 0 to 9. Okay, but binary numbers, the base is 2, so the digits that we use are 0 and 1. Okay, so let's go through some examples. I'm just going to flip my paper over here. Okay, and just first, before we go any further, let's review the powers of 2. Since we are going to be working in base 2, we need to know the powers. So let's start with 2 to the 0. Okay, anything to the exponent 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the 4, 16. Let's keep going. 2 to the 5, do it up here. 2 to the 5 is 32. 2 to the 6, 64. 2 to the 7, 128. 2 to the 8, 256. 2 to the 9 is 512, and 2 to the 10 is 1024. It would be really helpful to memorize these powers because that'll make your calculations much faster if you know them. Okay, so let's take a number. Let's take a binary number. So I'll take the number 101101. I'm going to put a little 2 here to indicate that that is a binary number. That's not the number 101,101. And we're going to convert this to decimal. So what happens is we got to remember that each one of these digits represents a power of 2. So this one over here represents 2 to the 0. And that one is 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, and 2 to the 5. So altogether, if we were to expand out this number, what the digits mean, we would have one of these. Okay, so 1 times 2 to the 0 plus 0 times 2 to the 1 plus 1 times 2 to the 2 plus 1 times 2 to the 3 plus 0 times 2 to the 4 plus 1 times 2 to the 5. Okay, and then let's figure out what that is. Well, 2 to the 0 is 1, so we have 1 times 1. 0 times anything is 0. 1 times 2 to the 2 is 4. 1 times 2 to the 3 is 8. This is a 0 times something, so that's 0. Plus 1 times 2 to the 5, so that's 32. And adding them all up, 32 plus 8 is 40, 44, 45. This 45 is in base 10, so I'm going to write my little 10 there. Okay, let's do maybe another example. I'll do a longer one. So let me do 1, 0, 0, 0, 0, 0, 0, 1. Okay, so what do we have here? This is the 2 to the 0. 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7. So expanding it all out, I can skip all those zeros because we know that they're not going to be added up to anything. So here we have 1 times 2 to the 0 plus another 1 times 2 to the 7, which is 1 plus 128, which is 129. Okay, so this was base 2. We should have written that before. This is base 10. Okay, so now we'll do some examples of going the other way. So now we're going to go decimal to binary. So let's pick a number. Let's go 72. 72 in decimal. So how do we convert this number to binary? Well, we have to look for powers of 2 that are less than 72 and start subtracting them away. What is the greatest power of 2 that is less than 72? Let's look at our list. Okay, which hopefully you'll memorize. But for now, you can just look it up. So the greatest power of 2 that's less than 72 is 64. So what I will do is I will take 72. So I'm going to take 72 and I'm going to subtract 64. Well, what's 64? It's 2 to the 6. Okay, so I'm going to subtract 64. So that gives me, I already know there's a 2 to the 6 in our answer. Right, now 72 minus 64 is 8. So I'm left with 8. And what is the highest power of 2 that is less than or equal to 8? Well, it happens to be 8. So 8 is 2 to the exponent 3. So I'll subtract the 8, and now I'm down to 0, which means I've used up all the numbers I need. So my number is going to go, it's going to have, if I was to make little dashes for the digits, I know I'm going to need to go up to 2 to the 6. So that means I'm going to need 7 dashes, 2 to the 0, 2 to the 1, and so on. 2 to the 0, I don't have any. 2 to the 1, I don't have any. 2 to the 2, I don't have any. 2 to the 3, I have 1. 2 to the 4, I don't have any. 2 to the 5, I don't have any. And 2 to the 6, I have 1. And so 72 in decimal is equal to 1001000 in binary. Let's do another example. Take a little bit of take a bigger number here. Let's try, I'm just going to use my calculator. Let's try 763. Okay, so 763, we're going to look for what is the largest power of 2 that is less than 763. So check your list. Turns out that it's 2 to the 9. 2 to the 9 is 512. So what I'll do, I'll take 763 minus 512. That's what I'm going to try to see what's left over. But the 512 gives me a 2 to the 9. So we know we're going to go up to 2 to the 9 in our binary number. So use your calculator if you need to. 763 minus 512 is 251. So I'm left with 251. I need the next, the greatest power of 2 that is less than 251. It looks like it's going to be 128 because 256 is a power of 2, but it's too big. So 251 minus 128 is what I'm going to do next. But the 128 gives me a 2 to the 7. So now I'll subtract 251 minus 128. It's 123. Okay, look for the next largest power of 2. Well, 128 would have been nice, but it's too big, so we'll use 64. 64 gives me a 2 to the 6. Okay, so what's 123 minus 64? It's 59. Okay, the greatest power of 2, less than or equal to 59 would be 32, which is a 2 to the 5. Okay, 59 minus 32 is 27. Greatest power of 2 is 16. Okay, and that gives me a 2 to the 4. 27 minus 16 is 11. Okay, so you can see, I guess I picked a good number because we have a lot of calculations here. The largest power of 2 would be 8. That gives me a 2 to the 3, and that leaves me with a 3. Greatest power of 2 is a 2, and that gives me a 2 to the 1. I'll just continue over here. We're almost done. And that leaves me with 1. The greatest power of 2 is 1, which is a 2 to the 0. So when I write my digits, I know I have to go up to 2 to the 9. So how many blanks should I put in? Well, I should put in 10 because we start at 2 to the 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and so do we have a 2 to the 0? Yes, we do. we have a 2 to the 1. We don't have a 2 to the 2, so that's a 0. We do have a 2 to the 3. We have a 2 to the 4. We have a 2 to the 5. We have a 2 to the 6, 2 to the 7. We don't have 2 to the 8. And we have 2 to the 9. Okay, and that is our binary representation, so I'll put a little 2 there. Okay, hopefully that made sense. If it's still difficult, please make sure you work with a classmate or you ask me in class and we'll get it all cleared up. Thank you for watching.